Okay, so part A here, you've got parametric functions to find parametrically x and y. So what we do is, to differentiate, to find dy dx, you've got to do dx dt first. Okay, so x in terms of t, so dx by dt. Of course, ln we know is 1 over, so it'll be 1 over t, and that's it. And then y in terms of t, so dy dt. While e becomes e stays the same, but of course you do times it by the derivative in here, which is 2. Okay, so you get that. Now what I tend to do, if I don't forget, I also write, as well as dx dt, I also flip this, dt dx. Okay, so I find the reciprocal of it, so if I flip that as well, you get t over 1, which is just t. That will help, because when it comes to doing the chain rule then, when it comes to finding dy dx using the chain rule, well, dy dx, well, you've got y on the top, so dy by dt, times then, well, dx on the bottom, so it'll be dt dx. Okay, so this comes in handy, after I've written the reciprocal of it. So dy dt is this here, just 2e to the 2t, okay, times then dt dx, which is t, okay, which is exactly what they want. So we can write it as they want it here, okay, tidy. Now part B, we want to get d2y by dx squared, which is essentially differentiating, isn't it? If you think about it, it's differentiating dy dx again, isn't it, with respect to x, okay. The only trouble is, right, it's not so straightforward, because if you want to differentiate dy dx again with respect to x, well, what is dy dx? Okay, of course, we know dy dx from part A is that. And the issue you've got is, you want to differentiate it with respect to x, but you can't. You can't, because it's in terms of t. So what we do is, we use this chain rule idea again. Of course, we can't differentiate with respect to x, but we can with respect to t. Okay, so I can do that, can't I? But if I change this, so I'm differentiating with respect to t, remember at the end I've got to plonk the dt dx there. Okay, got to do that, right? So that thing I've highlighted up here, I'm going to use again. Right, so you've got to plonk this at the end, and you can think of this as like, you know, if you think about it, the dt's actually cancel, dt on the bottom and the top, so you're left with dx on the bottom. So really, I haven't done anything wrong here, okay, just using the chain rule, but getting it so that I can differentiate this with respect to t, but then dt dx at the end. So differentiate this with respect to t, well, you've got to think here, I've got to differentiate this, it's a product, isn't it? So, you know, we've got to go through all that again. Okay, the product rule. Okay, so, you know, that's the only way to do it. U is 2t, so du dt is 2. V is that, so dv dt is, differentiate this, so we get 2e to the 2t. Okay, so when it comes to the product rule, then it's that times that, that times this. So this times this, 2e to the 2t. This times this, and 4te to the 2t. Okay, so that's what you get when you differentiate this with respect to t. So let's put that in there. But then, of course, don't forget, then you've got to times it by dt dx, which is t. Okay, and there's your answer. Okay, there's your answer there. I mean, we could actually tidy this up a little bit. We could factorize out things. We could take a 2 out of that bracket, couldn't we? You could take an e to the 2t out. Okay, and of course you've got this t here which times through, so we can put that t there. So, you know, you could end up having then 1 plus 2 here. So, have I done that right? 1 plus 2t, isn't it? Yeah, that's what I should have there, isn't it? Okay, I mean, you know, I've gone about this a quick way. You could multiply this out here and then factorize it, and you'll see then you get to this answer.